Hello all, welcome to the module. As a part of TA sessions, I will be discussing on electronic circuits that is required for designing a signal conditioning circuit for the sensor. So this complete TA sessions will be divided into 3 phases. In the first phase, we will be discussing how do we use an simulation software, electronic circuit simulation software, in order to build the electronics and analyze the electronics using the software. In the second video, I will be discussing on how do we design a signal conditioning circuit for the sensor. As in the previous sessions, it has been already discussed about the sensor and different sensors have been taught. For that particular sensor, how to design a signal conditioning we will see. Whereas in the third video, we will discuss on how do we interface the sensor to the data acquisition device such that change in the any variations happen in the sensor will be acquired, recorded, processed, then will be displayed to the user. As user may not understand or the end user may not understand what complete process happening inside the system, and it is always important to display the data where user has to understand about the input parameter. We have to do some kind of a processing. So in order to do that, we will be using a data acquisition where we will be interfacing the sensor and the related electronics, which is nothing but a signal conditioning circuit, to the data acquisition, and we will read the data and we will be displaying it on a GUI based app. So don't worry, all these videos will be maximum of 30 to 40 minutes. Each video will be of 30 to 40 minutes length. So I will be starting with how do we use a circuit simulation software in this video. Of course, there are different circuit simulation softwares available, but I am going to use online software which is Multisim. So in order to use this software, just go to multisim.com. So in order to understand, make you aware of how this circuit simulation software works, you just go to the resources. There we have option called Get Started. So in order to analyze any circuit, it has a total of 6 steps. First step, just create a circuit where you have to sign in, where we should create an account in case if you don't have, then just sign in into your account, then just click on to the create button. The next step is that whatever the circuit you are planning to realize, place it on the component area just by simply dragging and dropping there. So we have they have a database, a basic database available onto the online Multisim software. So such as, say if you want to realize a simple RC circuit or a simple resistive divider network circuit, so you have to place the component of, you have to place the passive components like resistors, capacitors, everything. Along with that, you also have to add a voltage source and the ground, and all these components will be available in the database. Just select the proper component which is required to realize your circuit and drag and drop it on your window. Then to just complete your circuit by wiring all the components. So by using a wiring tool, then after wiring, either you can select the values of the passive components while you are placing it, or after wiring you can select the values required for all the passive components or as well as the devices that you have placed on the window just by clicking it. After the selection of values, select proper response, whether it is an interactive response, just one time response, transient response, AC sweep analysis or DC sweep analysis. Then finally viewing the results. After this, just save your project so that in future if you want to refer the same circuit, you can it will be available in the server. So it also have multiple options. Just in order to explore or share the circuit, you can collaborate with the community so that you can discuss in the groups just by creating group, and then you can add circuit to your group, and you can even share the circuits to people too. So since being an online, it is more user friendly for the user to share and discuss in the online forums using the software. So further more about this working with the Multisim can be referred using Multisim website. There are so much of data available in the internet to understand how to use this interactive simulation software. So one advantage is you don't require any installation file in order to work with this simulation software. Anywhere, any place, if you have an internet availability, you can just log in into your account, then you can start using the you can analyzing your circuit as well as whatever the circuits you have already previously built. But you cannot use all the components available in the today's market, but however you can analyze the behavior of the logic. In case if you want to constrain yourself to particular component, then you have to better go with installation software, where you will have a lot of database available for each component. So we will start with the, building a small circuit. Just I am using my login account. So earlier lectures I have already recorded multiple circuits, so all whatever the circuits I have created, everything we can see here. So since our idea was to create a new circuit, I am just clicking on create circuit, which is available on the top right corner. So after clicking the create circuit, as we have already discussed previously, a new page will be open where you can see the schematic window. This is the schematic window, the white color completely. So whatever the circuit whatever the components available on the circuit has to be placed onto the schematic window. So you have on the top side, you can see three different modes. One is a schematic where you will be visualized with the schematic part. Then other one is a grapher. In order to analyze your data, output data as well as an input data with respect to the time, you can completely analyze. It is similar to the oscilloscope for the analysis. If you want, you can split the window, both your schematic as well as output data can be visualized parallelly. So as I already discussed, you have a different settings for your simulation to process: interactive, transient, AC, DC. Whenever it is required for the circuit, then I will be explaining about each and every simulation parameter here. So first let me save the file. So I am making it as a practice one. Okay. So on the left side, you can see different blocks. So first one is probe block, analysis and annotation, where you will have a probes for voltages, current, voltage, everything. Then you have a schematic connectors for grounding, junction, everything. Then you have a sources, you have AC sources, voltage, AC voltages, DC voltages, step, triangular, everything. Then you have a passive window where all the passive components like resistors, capacitors, inductors, potentiometers, transformers, everything will be available in this passive window. You have analog blocks like op amp, basic analog blocks, 3 terminal, 5 terminal, comparators, 555. Along with that, you have a generic IC of LM741 as well as 324. If you want to realize with another IC, like TL0, 84, 74, 72, 82, those cannot be realized using the online multisim. So, it does not have a complete database available with respect to all the ICs. However, there is a software available, a multisim software available offline, where you can install and you can work with the database. Then you also have a place for diodes too, where you can drag and drop diodes required for your application. Then transistors and digital blocks. Most of the the components that is required for our applications are available here for analysis purpose. So, in order to explain you, teach you the first component, I would like to realize resistive divider network. So, for a resistive divider network, we require to place two resistors. So, I will be taking resistor from the passive pellet. So, I am going to duplicate the same thing by copying and duplicating it. After placing it, when you take your cursor to end of the terminal, the cursor will automatically change from the hand tool to your wiring tool. So, indicating that now this can be used for connecting between the two resistors. So, I will just click here, so that I will start wiring. Then wherever it has to be ended, just click at that place, so that a wire will be connected between the two connections. In case if you want to delete, just press on the into button. I want to rotate it, the R2, and just drag and place little bit down. Now it is a resistive divider. So, in order to understand the working of it, after placing the component, the wiring has to be done. Along with these two components, we also have to place DC voltage source as well as ground. So, I will simply take DC voltage which is available in the sources pellet, DC voltage, then ground available in the schematic connectors, second pellet, just placing it. I am making a wiring between the terminals, right, slightly move it down, and the another terminal of R2 will be connected to the ground too. So, after wiring it, the next step is changing the values, in case if you require to change from the default values. I would like to change the voltage to 10 volts. Okay. Then this resistance to be of 10K. So, even this resistance I am selecting it as 10K. Finally, to visualize the response, I can use a probe, voltage probe. I can simply place it. If you want to even understand the current flowing through the circuit, along with the voltage, you can also use the current probe. So, here you can see the arrow, indication of an arrow. So, that means that if the current is flowing from the positive terminal to R1, then it is in the same phase. So, it will be shown with the positive. If the current is flowing in another direction, since the arrow is towards right side, and if the current is flowing in opposite direction, it will be indicated with the negative. Please do not confuse. Finally, I will be going with interactive session, just an interactive, then press run. So, I will go to the grapher. So, here you can see, since it is a simple resistive divider network and I am applying an input voltage of 10, and both the resistance of 10, both the resistances of 10K and 10K, as we know that it is a V by 2. So, since V is 10, so output will be 5 volts, and both the resistance are in series. So, the total resistance is of 20 kilo ohms. So 10 volts divided by 20 kilo, which is of 0.5 milliamps of current. So here we can see the 500 microamps, which is nothing but 0.5 milliamps. So it is matching with respect to our theoretical verification too. However, right now we can only see output voltage with respect to the time. Since the input is a DC, the output is also a DC, and it is of a constant since we are not changing any voltage. We are not changing any parameter, either input voltage as well as resistance. Okay. So now I am planning to realize a simple RC circuit so that we can use some other mode of understanding for the simulation. So rather than taking R2 as 10 kilo ohms, I will simply delete R2. I will replace R2 with a capacitor. So it acts as a simple RC circuit, charging circuit, integrating circuit or charging circuit. So 1 microfarad and 1 kilo ohms I am taking. So just running it, graph. Okay. Zoom all. Okay. So as we know how RC circuit works, initially it will pump current so that it starts charging. Once it reaches to the maximum voltage, the voltage across the capacitor will be always constant and it will be equal to your input voltage too. That we know about how the working of a simple RC circuit. But instead of realizing the initial phase of the complete circuit using interactive mode, I just want to go with a simple AC sweep. So this I will be replacing with a simple AC circuit, AC voltage, so that I can change different frequencies and see how exactly it is going to work. Now you can understand the filtering concept of RC circuit. So I will go to the settings of AC sweep. I want to start the frequency from 1 Hz to 1 e power 10 Hz. Okay. All the parameters looks good. In case if any parameters to be changed here, you can simply go to the settings which is available here. Then automatically the settings of that particular component will be available. In case if even for the resistance R1, you can see here the complete parameters of the model can be visualized here with respect to the symbols and the pin numbers, everything. Right? Just run, go to the grapher. So here we can see the border plot. So here what you can understand, so since I don't need the magnitude and phase for time being, I am not looking into the magnitude and phase for the input voltage. So here we have created a current as well as PR1, which is a voltage probe. I don't want to see the current information here. So I will disable PR2. In order to disable the PR2, simply go to the settings window of the grapher. Here we can see the cursors and the plots which to be visible on the screen. So I'm just deselecting the magnitude and the phase of PR1, and I'm just plotting only for the magnitude of the PR1 alone. Sorry, disabling the PR2 graphs and enabling only the magnitude of PR1. So here we can clearly see that. So after certain frequency, it stops allowing any frequency, which is a filtering output. And this is a simple low pass filter. So the border plot also looks like the low pass filter. That means it will allow the frequencies only particular value, after that it will not. So, in order to understand the cutoff frequency, you can plot the 3 dB. So, since it is 1, 3 dB lesser than that will be the value. So, that the cutoff frequency will be close to, so this is 1, so this will be 700 approximately. So, it is of around 125.89 Hz is the cutoff frequency. If you want to understand, if you want to see the cutoff frequency 1 by 2 pi RC, just analyze that and match with respect to the cutoff frequency. Any parameters to be changed, for example, say you don't want to change, you don't want to see the the frequency plot from 1 to 10 giga, rather than that it is okay if we can plot up to 10 kilo. So, in order to change the parameters, just go to the settings window here, but you have to go to the sweep settings window. So, just go to the schematic, then it will automatically goes to the sweep settings window. Then here, instead of going with 1 giga, I am going with just 10K. Then I am splitting the window, then plotting it. So, as I already mentioned, just zoom all everything, then magnitude and the phase plots of PR2 is disabled, only the magnitude plot has been enabled. So, auto fit magnitude. Then for better visualization, I am going to the grapher. Here we can clearly visualize. So, it is roughly around between 199 and 158. So, when we calculate the cutoff frequency, we got around 159 Hertz. So, even from the analysis we can clearly see the cutoff frequency of this is close to yes, this is 1 dB, 2 dB and 3 dB, 158.49. We got 159. That is a theoretical versus practical. So, I hope this is clear for you to understand how can we use an online multi circuit simulation software in order to realizing the basic for analyzing our circuits. With this, I will stop this thing. Any doubts you can please contact in the forum. Thank you.